All right, as with most presentations, we want to start with our giants are female, or in our case, we like the phrase our giants are human. This here is Lynn Conway. Now, she worked for IBM. This is the sort of biggest part of her story. However, at a very young age, she was affected by gender dysphoria. Okay, and IBM ultimately actually severed her employment purely because she made public back in the 60s that she was transgender. So in that process of working at IBM, she's more recently been credited for the fact that she was the inventor behind generalized dynamic instruction handling, which is out-of-order execution on a processor. So all modern processors have a cornerstone piece made by Lynn to our performance process that we have today. She's now very much known for transgender activism and is trying to sort of break these barriers that gender shouldn't be part of this story at all. It should just be everybody treated in a very respectful, proper manner. So that's my quick intro into somebody who's very cool. So I suppose we'll start off by talking about what we're gonna discuss, which is a bit of a story piece behind the project that we're working on at the moment, which we've called Dexter. We'll talk a little bit more about that later. But in general, it's talking about abstracting the test development itself by using custom steps, plugins, TestStand, and SystemLink as a distribution method. Now, quick show of hands, how many of you in the room here have heard of SystemLink or know much about it? 3 people in a room, that's not a lot. I'd have thought NI would have been really pushing this a lot more than they have clearly. It's a new product by now, but we'll talk about that
there is no
in a minute.
Free NI days.
That's true. So as introduction, this is me. I'm Larry Colvin. I'm an associate principal engineer at Dyson. I've worked there for 5 years. I'm an architect. And I used to work at National Instruments as one of those applications engineers who would probably not answer your question and probably off to one of the real experts when I was there. But since then, yeah, I've really broadened my experience with NI and also non-NI automation. So yeah, on to Barry.
Hi everyone, good afternoon. I'm Barry Jeapes. I'm an engineering manager at Dyson in the motors and power systems team, more specifically the motor drives and mass verification team. Previously, my last job was working with Alliance Partner, so I'm traveling around doing test systems for various people. I've been using LabVIEW for a really long time now. First version was LabVIEW 3, 27 years ago. So fair while. It's not been solid use for 27 years, but a fair chunk of that time has been. Been 6 years at Dyson, and I first used TestStand about 17 years ago as well. So I'm not one of these people who've gone down the certification route. Just stuck with the experience, I think. So
until recently, because we've all been pushing you to go get your
so I've started that process. Okay, just a tiny little bit about the team. So primarily, I'm welcome to read that, but primarily we're facilitators of test systems rather than doers of tests. So we generate test rigs, test software applications, tools, handle the test data management, do some production rig support. But we're more about facilitating other people to do that work rather than doing the tests ourselves. So we're a small team of 3 people. Really, there's a wide range of stuff we do.
Right, so talking of how this project started, Dexter, which I'm yet to explain what Dexter means, but I'll come to that, honest. We really just, in industry, have more than just 3 challenges, really, but these are 3 primary challenges that we have at Dyson and many other companies have as well, which is the fact that we are a large company. We have many different departments working fairly isolated from one another, so the communication is not 100% open, meaning that unification of how we actually all work on projects isn't there. How do we deploy when we're a massive company that's across multiple sites across the world? And how do we abstract our test systems in such a way that we don't actually just have to have LabVIEW engineers only developing this stuff? So these 3 challenges we wanted to really address using TestStand and LabVIEW and various other systems to try to bring a whole suite of software together that we can then encourage other engineers to to use to try to tackle these challenges. So to give a bit of background, when I first started at Dyson, or it's a bit later than when I first started at Dyson, because of course there's always that teething period of you proving yourself, able to do a bit of lab view. Eventually we were tasked with a quick project called, at the time, the Power Systems Validation Sequencer, which essentially I was handed an A4 sheet with a requirement on it saying, I need to ramp a voltage on a power supply in a random set of orders that I can define by some kind of file, and I want it to log the measured power on one of our motors in doing so. So I thought, great, cool, fun project. I created a LabVIEW bespoke application that allowed you to use tree controls and lists in order to drag and drop various actions that would connect through to the power supply and do all manner of things. Of course, as with most software that is successful, we suddenly had an influx of loads of other departments and engineers deciding, I want a piece of that as well, except not quite like that. I want it to be slightly different with this added feature, or I want that added piece of hardware and so forth. So for a couple of years, I was tearing my hair out, constantly having to update this piece of software that I started to hate because of the amount of maintenance that you had to put into it. So eventually we were talking through and strategizing how we're going to deal with this problem, because I can't do this for the rest of my life. So we got the investment from a company to say, well, let's take it back a step then, and let's do this properly in such a way that looking forward into the future is scalable and maintainable. So this is how Dexter was born. And Dexter is essentially an umbrella project that contains multiple sub-projects here at Dyson, but it stands for the Dyson Extensible Test Rail, which, catchy name.
So it's not the lab that you work in?
No. I originally was putting sort of the iconography of Dexter's lab in there, but Barry wanted it to be a bit more professional. So yeah, in this, using Dexter, we hope to meet all of these challenges. And just to sort of give you an idea, we're going to be providing Dexter both to engineers here who are actually designing the tests themselves, because we are facilitators. We don't actually know much, to be fair, about real in-depth motor control stuff. That's what we have scientists for at Dyson. But we want to not have to sort of get the scientists to get us to do the thing. No, we want to provide them the tools so they can make it themselves. So we're hoping with the Dexter platform, we're going to provide engineers with the ability to create these test sequences using TestStand, and then we'll have operators that can be stationed in Singapore, Malaysia, wherever the site is, where they're going to be running certain tests. They will be running the same tests that our engineers have created. So, challenge 1, unification. And I can't remember who was going to talk about this, Barry.
Yeah, you were doing a good job. Carry on.
So, to give a little bit of a, I suppose, a bit of another background piece. Dyson's such a big company. It's been going on for quite a while. I mean, we're talking thousands of employees, many billions worth. And hence, with that, we've got many teams that don't even know each other exist. And they're only literally in the next room along or something on site. So if we're talking about, for example, architects, certified architects at Dyson, I think we've got in the order of 15 now architects across Dyson. Right. Many CLD people, including Barry now, CLD. And so if you can imagine, everybody works in a different way. One of the things that we're trying to do is we're not trying to take away from other people's work, because everybody's an expert. We're just trying to provide a common platform that sits underneath, that's very open, generic, and is familiar, because one of the key things is that when you travel between projects, you want the familiarity of the tool that you generate, the output, but also the input to be pretty much the same across the board. It means the output of your tests is much quicker turnaround. So one of the things we wanted to unify, obviously, is the process of creating tests. We also wanted to unify the data that was output on the other end. This is what TestStand's great at, report generation. We can really hammer down on exactly how we want our reports to come out the other end, and we can start to include pieces of valuable information that have been omitted in the past because it's not being thought about by other teams and so forth. The other thing as well, in terms of unification, if you, out of the companies here, how many companies have multinational sites that they have to operate with and communicate with?
Not our company, but the one
Yeah.
I'm working for now.
The one you work on now.
Abaco has sites in America and the UK.
So hopefully, I mean, I don't think you really need to have this to appreciate this problem, but if you can think of like another team that's on the opposite end of the world, you've designed a test here that runs and produces a particular output. Now, if you were to hand that test over to someone on the other end of the world, and they ran the exact same test with the exact same inputs, you would expect the exact same outputs. But the actual probability of that happening seems to be really low. And the reason behind this generally is things about environmental factors. It's not just I'm talking about noise and things on your measurement lines. I'm talking about the communication of how the hardware setup is meant to be. The test sequence itself, or whatever LabVIEW application, whatever you've built to run the test, has to run the same both ends. And more often than not, it has to be tweaked in some way just because of something is not possible somewhere where it is somewhere else. So again, another unification piece is such that when we generate test sequences here, we want to know for sure that when we send these test sequences over to the other end of the world, to one of our other sites, that when they run it there, we can actually trust the data that's being generated and not have to question every 5 seconds, have you made sure to set it up in such a way, blah, blah, blah. So in this, platform, we're sort of providing ways in order to make sure using, well, to give you a little bit of detail, using checksums of the actual sequence files that we send over with part of the model plugin checking whether the sequence is validated or not to make sure that it's allowed to be run, make sure that the sequence hasn't been tampered with between 2 locations, and we can guarantee that the same exact sequence has been ran on both sites. So I'm trying to run through this quite quickly. I don't know, it's verbal diarrhea when it comes to Larry.
Now
so-
I sort of understand the question you were asking earlier. How do you verify the sequence hasn't been modified? Is that
That's a good example of why. Yeah.
It's probably been hit with a few times where operators or engineers who are doing the test worked out how to change something, and they've changed things with all good intentions, but it's changed the integrity of the test. So we get things, we increase yields where it shouldn't necessarily be the case, or that sort of thing.
If your job is reliant on having a certain yield output, then you want to make sure that your test has that yield output. And if it's done in the correct way, because your thing you're testing is great, that's cool. But more often than not, it's done in a way of just tweaking it in such a way that I've got the score I need.
But can I ask a quick question before we go in? Well, the operator shouldn't be able to touch the source code anyway.
Yeah.
So is there a problem with the process where, like, I've been with companies where they use a full TestStand sequence editor on the production environment, and basically anybody can do anything with them. And it has happened that 2 months down after production, they found issues. But one way to avoid it is you lock down the file, make it read-only or whatever, and 2, you give an operator interface where you don't allow any changes to. So they get one button which says run.
Sure.
That's very true, and the issues we're highlighting that we've had in the past haven't been with test standards. They've been with bespoke test systems that other people have created that have PE files that the engineers operators have found, that kind of thing. So test standard itself does kind of help batten the hatches a little bit with respect to that.
Well,
I guess we just want.
Yeah, I mean, to be honest, I mean, you could take the test and sequence away and modify it somewhere else and bring it back.
Yeah.
So that's still possible. I mean, even because now you can open it, not now. I mean, you can open it as an INI file or an XML file. So editing is possible. So you can just search and go for the limit and then do it. Not that I've ever done that,
But you'd be surprised if someone's determined to change something.
Yeah, exactly. So Abaco, where I used to work for a while. I mean, so Matters then did a plugin which basically checked it out from the source code control, checks it, and then at the end of the test deletes the files. So I'm sure Matters is raring to go, but go for it.
Yeah, we'll talk about our kind of solution to that problem a little bit. Come to this. So the next challenge was deployment. So we're using 2 primary tools in this study updates. So first of all, we use NI Package Manager, which I'm sure all of you are familiar with now. You're installing NI tools, and the other one SystemLink. So NI Package Manager is essentially installed on every machine including production machines, your process machines, and so on. So obviously it has some great advantages, easy to update, rollback, remove, repair packages, and it has a great LabVIEW API, so you can kind of automate a lot of those tasks as well from within LabVIEW using the NIPM API API package. SystemLink does many things. We currently have it installed on a VM, and our primary purpose is to facilitate basically the package repository. So we create packages for our TestStand sequences and the core of what we're developing, and the SystemLink helps us kind of distribute that to the global network of people using our tool. And again, there's a LabVIEW API to help us to facilitate talking to the system remotely, so we can help automate those tasks.
This is. I'm just going to point out what SystemLink actually is. Okay. In a general, so for anybody who doesn't know what SystemLink is, it's essentially a server that you can run, and you can pay for a certain number of servers. You can have nodes, which are clients. Now, these clients, they automatically publish data to the server to define what their current state is, whether they're running tests. You can see even from the SystemLink server to its client nodes what specific sequence they're running and where in the sequence they're particularly running. It's able to collect data off of your clients and actually pull them into a central area where you can do simple queries on this data to find sort of data ranges over dates and various other things. So it's a quick, easy, web-based means of looking through your information as well. And it has a host of other things, but as Barry mentioned, really one of the key things that we're playing with is the fact that you can host package repositories, which you can also do locally by pointing it to a specific network share or file, but this is far more of a web service-based thing, so it's a bit more sort of like you'd expect in the modern world web browser. You can browse things, download certain things, and it's a really powerful tool. I would highly recommend at least investigating if you haven't heard of it. NI SystemLink. It's relatively, if you think about NI products, cheap. I mean, we're talking there's a cost behind the server and there's a cost per node as well, but actually we're not talking stupid money. I'm not going to quote any figures though, because I never remember them. Yeah, just in case we've got a special deal. No. Sorry, I'll hand back to Barry to continue.
So just to talk about our development and deployment process. So this is specifically talking about Dexter core, which is the kind of updating the process model and the plugins that modify TestStand, and the custom steps that Larry has created. So it's pretty much the same process for both things. So we do the core develop process models, edit the customizations, develop the operating interface, so on. And for the custom step type, you edit the UI, create the action actor, modify types files, and so on. And then there's a fairly manual, obvious kind of build process. So in your LabVIEW project, you have your DLLs, your LLBs, and your packages. You basically set them out, configure them, build them manually. And then there's a publish to SystemLink stage where you create a package and you can manually upload that to the correct feed URL in SystemLink, so it's available to the correct people. And just so where you can, in NI Package Manager, you can add a feed. So you're given a URL of where your packages might exist. You're able to have basically add that feed into NI Package Manager, and that gives you access to all the packages within that feed, in that location. But that's a fairly slow, slightly tedious process. So we actually have a VI to automate that entire process. So I'm going to demonstrate that in a few moments. Which what this really means is we can do our development, we can automate or do all our build and publishing in kind of one click of a button, and immediately we're testing real code that exists there for us to use. So it's really, when you mentioned earlier about test often early, it's kind of really helps facilitate that kind of process.
And also just one quick one, just because it's going up to SystemLink and your clients are then going to have access to this new updated package, it means a turnaround time to testing it not on your own machine, because as we all know, as developers, testing on your own machine is not good enough. You need to test it on other machines in different situations. It's very quick to have a bank of PCs, all with different hardware or software setups, all updating the package and still rerunning and checking that things actually work. So it's good for that.
So I'm just going to do a quick demo here. I haven't got a mouse, so I've used LabVIEW with a tracker pad, which I hate doing. There you go.
I can walk to see the nice I'll grab this one.
Cheers. Thank you. catch up. So this is a lovely project for the core functionality of Dexter, which is our NI version. So I have TestStand here. No, it's there. Just as a quick example, this is all kind of things that we've kind of set up, but there is an about box for Dexter. It's there. So for example, this shows us the version of the core packages installed and so on. So what I'm going to do very, very quickly, do a very, very quick change to that and show you how quick kind of process is to modify code. So close TestStand. So she's now being blind. There we go. So basically what I'm going to do, rather than, I'm going to add very quickly a function here. So basically this is an about box. It just shows you the information about Dexter. So really what I'm going to have here is just a quick dialog that says, are you sure you want to close? Great. Constant. Something else. So really, sorry, this minute. So yeah, there's a really simple change. Now when you close the dialog, the about box, you should kind of ask you whether that's really what you want to do. My automated build process is here. Directly and great machine. So I've built into this different things it can do. So one thing this is really useful for doing is including version numbers. So we actually interrogate the XML of the project and pull out the details about the description of the build and so on, and it automates all the builds of all the DLLs we use inside TestStand, builds in a package, archives the old packages that exist and replaces them with new ones, and it can also, which I'm not going to turn on right now, it can automatically install the package. But because we're remote and we've not got a system in here, so I'm going to have to kind of skip that bit. This takes about 30 seconds to run. So yeah, so the really useful thing about this is, like I said, it's just a really quick, fast way to quickly deploy and test your code. It's a shame I can't show the SystemLink bit working. You just have to trust that the package that's created is automatically uploaded to SystemLink and available in NI Package Manager after that.
So we here regularly build NI packages at all. One. So this is where that package is going to appear. It's going very slowly actually. I suspect I'm being jinxed by the demonstration gods. I've only run this about 5,000 times before and it's worked fine, so it does appear to have just got stuck. Okay.
What is the thing of like laptops running on battery? They just
I think that's part of it. I think we waited long enough, it would go, but with short time, so I'm going to try and skip on. If this happens to work in a minute, if it does catch up, I'll get back to that. But in the interest of time, I'm going to go on to the next stage. So if that works, I'll come back to it. So the next thing about deployment, the other thing that's really, if you remember from the our kind of objectives and challenges, one of them was to be able for engineers to be able to create the AT themselves. So along with the custom step types that we create and supply to them, which Lara's going to go over shortly, we give them a tool to basically package their sequences directly. So there's an option within TestStand we've created that uses the NIPM API and SystemLink API to, first of all, it works out all the dependencies within that sequence, knows what they all are, creates a package using those tools, publishes it to SystemLink, and then immediately that sequence is available to the operators and so on, kind of globally. So it's a really, really good, powerful tool, and we don't have to get involved directly. So we just give them the tools, and they can just go in and build packages. People who know about, the detail, the test how the motors work, and so on.
That's potentially very dangerous. If somebody builds a test that's not actually doing what it's supposed to and says it passes, and everybody goes, "Oh, brilliant, they all passed now."
Well, there is a process you go through. So while an engineer is developing a test, what they don't need to know about is the detail of how you communicate and talk to a power supply or a power meter, so on. So they have these abstracted custom steps that allows them to create a sequence and sweep things and test things and so on. They test that locally using this and a sandbox kind of feed URL on SystemLink that isn't available to everybody, and only when they're happy with that will they distribute and package that and send it to the global teams to use. So, and like we alluded to earlier, there's a process for certifying our packages and sequences. So they have to make sure that to go through that process, there's a bit of due diligence and verification and approval by various people to make sure they can do that.
Right, that's sensible.
Yeah. Yeah, so this is a kind of really useful tool. This is the key part that made that whole empowering engineers to do the work, the thing, really. So that was quite nicely. Still a bit of work to do on that, but it's getting there.
All right, so the third challenge being abstraction, of course, as we all know, especially by the NI mantra, which is the idea of we're not all computer scientists, we're engineers, but LabVIEW kind of gives you an engineer the ability to do some programming. Well, in the same way, TestStand, I would say, well, why abstract? TestStand has probably one of the steepest learning curves I've seen across sequences. It is incredibly powerful, don't get me wrong. It's a brilliant piece of software, but getting started with TestStand is a lot to learn. So what we want to do is we want to reduce that complexity through abstraction in such a way that the nitty-gritty that people have to do in order to, from a completely stock piece of TestStand, get some measurement values out of, removing those types of hurdles and challenges and focusing more on the high-level hardware interaction to facilitate a test, means that we can get more engineers on board designing their own tests rather than having to rely on us to do what they ask us to do, meaning we're trying to get rid of our own jobs, ideally. So what are we trying to abstract? Well, one of the key things that I hate in TestStand, when you're simply calling actions or pass-fail tests for VIs as a good example, if I'm talking to a piece of hardware and having to constantly think about how I'm going to deal with connecting to the piece of hardware first, I'll call the connect function. That's generated a reference for me. That reference I'm going to need to pass on to the next function to perform an action. How am I going to do that? There's a million and one ways. I could put it into a local TestStand variable. I could hold it into a variable in LabVIEW, hidden away, and then collect it somewhere else again as well. All of these questions, all of these methods mean that there's too much sort of ambiguity. What should I be doing? So by removing the need for any reference handling and any sort of nitty-gritty with the hardware control, again, hopefully people can just get on and design these tests. Now, I'll say one thing. One thing we're not doing through abstraction is removing any functionality from TestStand. We are making sure that TestStand can still be ran 100% stock, such that if they might make their own custom steps or if they make their own LabVIEW modules or other modules in other languages that they want to call, it will still seamlessly work in among the model plugins and custom steps that we've created for people as well. So one of the other things that also isn't quite clear, I mean, I've kind of already mentioned it, is this how do you handle variables, numbers, and values and things between LabVIEW and TestStand? There's so many options for you that we kind of came up with one, and we were like, yeah, let's just do this. So in order to facilitate a lot of this hardware control, what I've been doing is I've been building a library of common hardware that we use at Dyson in verification testing, in order to provide an engineer quite an easy thing of oh, I'm at this bench top power supply, I'll just select it from that list and drag and drop. It's not quite the hardware abstraction layer that we expect from TestStand in the sense that, you know, it's generic power supply. No, I'm actually building a custom step for each individual power supply, but they're all based off of templates and things which are similar in essence. I don't have to recreate work every 5 seconds. It's just to keep it very clear to the developer. I don't like just having power supply and then hiding away how we're choosing
And,
what API we're calling in the background.
and I think it's worth mentioning that at Dyson we have, certainly the motors and power systems team, we have a set of hardware that's pretty fixed. So we're not regularly changing power supplies and power meters and so on. So we know which hardware is going to be used for various tests. So adding the hardware abstraction layer was probably a step we didn't need to take.
Maybe in the future. There's nothing stopping us from in the future creating a custom step that is an abstracted version of this abstraction. But generally, the way we want our custom steps to work are all in the same way. So this is where the unification piece comes back in again. All of them are a drag and drop of your custom step. What it will do is it will open an edit time screen. What this will provide you with is a tree control based on all of these actions that this module can do. Now, what this module will then do, you'll choose your action, define your parameters. All of this information, this is the background of the edit screen, is actually being saved through using your sequence context back into the step's actual configuration under its step settings. So TestStand knows all of the settings you've applied here, such that when it comes to runtime later, it knows what it needs to do. So what does actually happen at runtime? Say I've made a sequence where for the QPX power supply, I've pulled in a whole list of different actions I wanted to perform. Under the hood, we're simply actually just talking to, well, for want of a better word, an actor in LabVIEW, or let's call it a module. It's one of these typical dequeuing things where it just has an API set for it that we've generated that we can pass values to. Now, whatever the action was that we've set up as a command, it will call its relevant API, send it to the actor, and the actor can then interact again with other pieces via 2 methods. It can either bind data the actor generates, so say the power supply in this QPX 1200 SP will be outputting a voltage value. Now, that voltage is a variable. That variable can be stored in the LabVIEW domain, or it can also be stored directly in the TestStand domain via binding, which is this idea we're coming up with, and this concept we're going to have to teach to the engineers who are going to be taking on this system. And this binding basically simplifies how you're going to get modules that are separate, different pieces of hardware to interact with one another, or even taking that information you've got from a piece of hardware, getting it to a log file. Hopefully, I can demonstrate this. Yeah. I think this opens. Yeah.
I think if you just start it, it will just.
Yeah. All right, so back in TestStand again.
Just a second. Are you guys able to see the TestStand online, guys?
Yes, we can see that. Thank you.
All right.
Okay, excellent. So, firstly, I've got down here on the left-hand side my custom steps. I've only got a few installed. We've got a library of them back at home. Some of them are just sort of simple power meter, power supply, actors, AC, DC, power supplies and things. But let's talk about using a template. This is my base template I come up with new modules for. But the template is kind of like a simulated thing we can just run out of the box anyway. So let me demonstrate what it's like initially as to how we work with the template. So if I drag and drop the template across to the center of a screen, it will bring up my edit screen. I have that action on the left where I can choose what I want to do, disconnect, terminate. Now, I just want to connect to the device. Of course, it's a simulated device, it's not real. Don't worry. The first thing I'm going to have to do is I'm going to have to give it an ID because I might have more than one template. In this case, let's call this a power supply. It's a dummy power supply. We'll call this PSU1 and we'll hit OK. Oh, I didn't mean to click there. So let me just pull this mouse out. That's better. Okay. So I've connected to my power supply. You may have noticed, of course, that if this were to mimic a piece of hardware, I have not in any way said how to connect to the piece of hardware. It's like with serial devices, you'd usually be expected to put in a COM port number or visa, or for TCP, you'd be putting in an IP address, for example. That's not defined here. And the reason we don't define it here is because if I give this sequence, when I've made it with my pieces of hardware where I've got it enumerated COM123 over to that person, when they set their computer up, COM123 might now be COM7, 7, 8, and 9 on their PC. So the actual definition of the actual connection to the hardware is done at a later stage, which we'll see in a second. So I'm connecting to my power supply. Let me just draw on a few other actions it can quickly do. So first of all, I might want it to be polling some variable, because this one by default has some random number generation and string generation inside. I'm going to make it run at 10 Hertz. So it's going to generate random numbers and random strings at 10 Hertz rate. Next, just to see that it's doing something, what I'm going to do is I'm going to open its UI, which is its front panel when it's running. I can define all of the information about how I'm going to open that UI. I'm just going to open it up in default, which is on monitor 1. Just to show you where it's storing this information, if we look down in the settings, I've got all of this information down here. So the UI information that I've just defined is all written in here. You'll also notice that all of these values in here are values and variables, because we can't only, if I re-edit this, I've got 2 columns in which I can define these values. On the left-hand column, these are effectively the scalar values of what you want to set it to. But imagine if we actually wanted to make it generic and we wanted to feed in via some variable what that value should be. Say I wanted the width to be defined by a TestStand variable. I can write in here instead locals dot screen width. Okay, if I hit OK, it will notice, oh dear, you don't have locals.screen width yet in TestStand. Do you want to make it? Sure. I'll make locals.screen width. So I've got that one up there. Now, what was the value meant to be roughly? I can never remember. 1280. I'll just keep it sort of similar. So 1270. Why not? Okay, so now, because I've set a variable for that value, it's always going to take that as precedence. I eventually want to maybe close my UI when it's finished. And I also want to disconnect because I'm disconnecting from a piece of hardware. Right, so I can save this already as it is now. Oh no, I probably want a delay in there as well. Barry's right, because otherwise it's going to run very, very fast. I'll just call this sequence file 1 on my desktop, that's cool. And as Barry suggested, I'll whack a little wait function in the middle of, say, 10 seconds, because we might see something. Right, I'll save this and I'll run it. And I will demonstrate what the first thing is that happens. We're not going to be running anything yet the first time you run a sequence, because we've never defined how we connect to our hardware. And because the simulated device is classed as a piece of hardware, as a hardware module, it's listed it in the instrument configuration wizard, which always runs if it doesn't have a configuration yet for this sequence run, in which I can define in here, well, PSU1 being one of my resources, is COM999. It's not real. And I can hit confirm to say, this is my setting, and it's then going to ask me in the standard way, except with our own dialog boxes, because we don't like the way TestStand looks, some things like our serial number. So 1, 2, 3, 4, 5, 6, 7. I hit OK, it runs it. As you can see, it's opened the front panel of that thing. Very hard to see what I'm doing looking at that screen, for that screen. And it was just running something. It did something, and eventually it generates the report as we expect as well. Look at this screen, Larry. And you'll see in the report we've got all manner of settings, how we configured things, and whether the step was successful. Opening a UI defaults not being reported because, of course, it's not really that important to see. So just to extend very, very quickly on top of this, so to do with the binding variables, to give you an idea behind that. So say I want to actually log any of this information. So it's useful seeing it on the front panel, but actually logging it, I've created a module called the CSV logger, because this is embarrassing, but Dyson still massively heavily uses CSV. They haven't all moved to TDMS, unfortunately. So, of course, the first thing I was tasked with is make a CSV logger, because people are happy with it. People are happy with commas. So let's create a CSV file. So I'll drag this in, and it's a module. It uses the same edit screen, except it's colored differently. So there again is this familiarity. And all we've got to do is configure it. Of course, we can have more than one logger. So again, I've got to give it an idea. I'm going to call this Larry's log. Okay. And I'm going to log at a rate of 5 Hertz. Now, this data file. I'm going to call it Larry's data. And there's a few defaults that we can append to the file, and I can select my variables. But I haven't defined any variables of what I'm going to log yet, so I'll come back to that in a second. I can also give it a header of random header stuff, so header stuff for the file. Let's hit OK on this OK, and we'll come back to that setting to define the variables in a second. So to define the variables, let's define them in the template, because we need to bind its values to something. So if I pull in another setting before I start polling on this template and look under data variable, I can bind a variable. If we look inside my parameters, this is defined inside the actor itself, what it can generate, which in this case being a template is a random string or a random number. So I'm going to choose a random number, and I can bind this to two types of variables. They're all described on the side here, but I can obviously bind them directly to a TestStand variable by simply writing, let's say, locals.number1, okay, or number TS, because it's the one for TestStand. I'll hit OK. I could also, with that same template, put to a name called number LV. I've not put any of the precursors of locals, parameters, file globals, or station globals in front. So that's how we distinguish between whether we're binding it to essentially what is a notifier in LabVIEW, or whether we're binding it to a TestStand variable. So we've bound two values there, which means if we now go back to our configure and edit this step, we'll suddenly see those variables listed here as variables we can put in there. I'm going to give them two headings. This one is definitely TestStand on the first one, and this one is definitely LabVIEW's log of a variable that we bound, and we hit OK. Now, finally, we obviously want to start the logger at some point, which will log once we've opened the UI. Start. And we want to stop the log at the end as well. So stop, it's already chosen stop because it sees it's in the cleanup stage. Save it, and I run again. Now, you may expect it will come up with that instrument hardware configuration again, but it won't, because we've already configured our template, which is a hardware module with a configuration. The CSV logger isn't a hardware module. It's defined as a normal standard module, whatever we're going to call it. And that means that this time when I run it, it's just going to run. Well, serial number first, I suppose. So this serial number we'll put in 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Hit continue. And again, we're running what looks like a similar same sequence as before. We'll eventually get there. It will close. We've got our general report. What I can also do, it tells me where it is as well specifically, but I've got here. We used to have a banner, but I think in recent development, I've downloaded and installed the wrong core Dexter piece, which means the banner used to come up saying pass or fail, and it would also show you where the data was with a link. But, oh well. So let's have a very quick look in there. In this data folder, the serial is split by serial numbers. These serial numbers will also then have a timestamp and date placed on them as to when the sequence was ran. We look inside, we've got our report that we've got come from TestStand. We've also got our Larry's data file. If we take a look in Larry's data file, it's a CSV file as we would expect. Oh, God. Oh, no, it's fine. And for some reason, it never logged anything, because this is what always happens with every demo I ever do.
You missed the start step.
Yeah, something like that.
It's the demo gremlin.
Either way, this would usually work. I tried this morning, it works. Just like Barry tried his thing this morning, it works.
You configure the PSU1, but you don't actually start it.
That's here. CSV logger start.
No, not the log. It's not the logger that you're not starting. It's the template.
Ah, very good spot. I'm never actually generating any actual data. My bad. So I should be starting logging there. Yeah, you're absolutely right. And also at the other end, probably stopping that polling action. Very quick rerun then. And you can see, I never actually looked to see if that data was being generated. Whoops, my bad. I also built like a, oh, too slow to click it. Built a little mini event info like screen as well, because everything actually under the hood doesn't use queues. It uses event handling in order to transfer of messages. So looking back at that same folder again, one back, we've got a second run over here. Larry's data, come on, this time.
Some more data this time.
Come on. Yay, there's some data.
Okay.
So just select that crap. Go along, and there's some information that we've been logging in the background.
I think the real powerful thing about this is you can have data from your power meter logging at the same time as your power supply from that work you're doing, all logging at the same time to the same CSV file or multiple series files if you want to.
Now, what I was gonna quickly show as well is a process of updating one of these modules in a similar way that Barry was going to build something, but that's undoubtedly going to go wrong. So just to give you a quick sort of overview as to the template library project itself, it is actually not that hard. I've got two VIs, edit step and run step. These are defined under a custom step type inside TestStand as either the edit time screen to run or the runtime screen to run. These are simply the menu system itself. The actual underlying, my computer has decided to freeze itself, but no, it's getting there. So as you can see, it's just an empty screen. There is no definition inside here at all about its commands or its edit screens. That is entirely done by a system of defining VIs. I've got loads of VIs here, like connect. If I take a look at connect, there's no code in it other than this one repetitive piece that's used on all of the commands, which is basically just initializing the controls inside to sort of set it to the last ID you used, for example, and gives you an option of selectable IDs if you define multiple of the same module. So really the code behind a command is entirely defined by the name of your controls that you're filling your details into. That's where it stores it as a step setting. So as you can see, step settings ID var, whatever I fill into this box, that's what's going to end up in TestStand. Now, the underlying code that actually runs the things are called states, and these states are called based on the name of a command. So connect will call connect. And in this case, being a template, it doesn't do much other than a little bit of sort of adding a few pieces of information to the report. So this is kind of generally how it works. There's a bit more to it, but I think we're running out of time, I suppose.
It does mean it's very, very fast to add functionality to each step. So you just basically edit the edit screen and then add a VI to handle that message or that function.
And then again, usually it would be double click an automated build and it would take maybe a minute and a half and you reopen TestStand and all these changes are built in there as if they've been deployed on an end user's machine. So that's quite good. Going back to presentation, Harry, you just for the last slide. All right, so as a quick wrap up, I wanted to just mention the challenges we're currently facing, because this project is in nowhere near finished. We've come a long way and we're on the cusp of our actual first deployment to our developers to develop sequences. The problem is there's still big challenges to overcome. So first of all, SystemLink is still in early days. It doesn't actually have an org policy, which means there's no means of saying you're allowed to see this particular repo, but not that one, and you are not allowed to see this. So there's no policy behind user management. At the moment, the workaround would effectively be buy a server for each dedicated group of people. It's not really what we wanted to hear, but we have recently been talking to them and they said it is on the roadmap for next year that they're going to have an org policy system built into SystemLink to allow you to do much more fine-tuned control as to who can see what data and repositories and so forth.
So can you have different feeds for different user groups and then only publish those user feeds to those users? I mean, so which means that that's the only thing that's registered to them.
Yeah,
Absolutely.
that's true. So that's only secure in the sense that as long as nobody shares that.
Exactly. Yeah.
So that is a crude way to control that. And also in the tools ourselves, we're kind of devising a way to kind of limit what people can access and so on. But
And that kind of links into the second point, which is NI Package Manager itself doesn't really do any verifying of credentials. It doesn't look at your user account and ask the server whether it's allowed to take this package file and install it. It just does it if it sees it.
Yeah.
Whereas if we have an org policy, probably NI Package Manager has to change in respect to that to allow you to fill in details about your organisation.
That was in the roadmap at the same time.
Absolutely.
I think May next year, they said.
So the other thing is, although we showed you a SystemLink API for LabVIEW that allows you to automate things, it's entirely not supported, and they couldn't tell us exactly when they'd make it supported. We haven't at all in this project yet tackled that piece for SystemLink to really do the test data management piece, because we just haven't yet really generated much data. The other thing we found as well, if you play with NI Package Manager, is dependencies between packages is entirely not obvious. You'd think if I built a package and I said include the dependencies, that it would include the files it needs with your package, but it doesn't. No, it actually just puts relative paths to other feeds where it can collect the files it needs. But if those feeds don't yet exist in NI Package Manager on your system because you haven't yet discovered them in your feed list, then it just says, sorry, I can't find this package. So then you have to do all kinds of management about what we can do as at the moment is on SystemLink. We can take our package, look at its dependencies, and clone the dependencies from other feeds into our feed. That way the package is available the moment they want to install it. It installs all the dependencies for them all in one go. It's a one-click thing. So it does work. It's just not straightforward and it doesn't make total sense. We've complained about it. But we'll see. We'll see. And something else we have really not tackled either is making proper use of the sequence analyzer, especially with something like this. We've customized TestStand enough that there needs to be a process behind how people build these sequences. So we're going to really have to customize the sequence analyzer such that they don't build stupid sequences at the end of the day.
Okay, the certain rules we want them to abide by.
Yeah, absolutely.
We need to force those rules.
So these are the big things we're kind of trying to work on at the moment.
So the sequence analyzer is a good segue. I mean, so this is one of the presentations in the feedback form. So if you'd like to see something on the sequence analyzer, please vote for it so that in the next one we can do it. So please fill in the feedback form before you leave. I mean, that would be really useful for us to organize the next one. But have you tried the package builder?
Yes.
And that hasn't helped with the dependencies at all?
No, because it still is reliant on just collecting feeds together. So unless you've defined your feed to contain the packages it needs, the other feeds have to be registered on the endpoints NI Package Manager to go collect the files. It's not that your package can contain those feed links. It just tells your NI Package Manager to go collect it from a specified feed.
A good example of that is if you go to a completely fresh machine with no NI at all, and you install one of your a little custom LabVIEW you've created, and it needs a runtime engine. If that feed doesn't already exist on that machine, it will say can't get the dependency.
Oh, so it can't even pull things from like the NI core.
No,
No, that's exactly what I mean. If it's not there already, because it's a catch-22. To get the feed of the LabVIEW or LabVIEW runtime engine, you need to go to Browse Products and install it. Once you've installed it, it adds the feeds during the install, and that's how it maintains its updates and its packages maintained by NI.
And what it does actually, before you've installed NI Package Manager or whatever, it basically, or you upgrade Package Manager, it will just scan all the NI software on the machine and add all the feeds associated to those packages, those functions. But for clean machines, it just doesn't work.
Yeah, no, I thought you were talking about like, because obviously you said you've got like multiple internal feeds.
Yeah,
I thought you were talking about between internal
Yeah,
feeds.
that'd be easier.
The fact it doesn't work with even like the core
Yeah,
ones.
that's
Yeah.
That's easier to manage for us.
Yeah.
What we have done recently on SystemLink, this entirely web-based. You can set up your repositories entirely on the web, and it's got some cool tools, of which, for example, you can clone things out of the ni.coms download section, which is the NI's feeds. I did recently just try to say select all on the 20,000 products that you have just install, and yeah, about 10 hours later I had to go home and I can't leave my laptop at work, so I just had to abort the thing after it had done about 10% of it. So it is possible, I think, if you've got a big enough server.
Yes, it is warrants investigation.
Yeah,
But I think it's
That's
a problem that I need to fix.
Oh yeah, there's definite problems with it. So.
Yeah.
Yeah,
But
the
the whole
other-
this thing is really promising. The way I'm with a system and just being able to control, really fine control of it, who has one. It's
Yeah,
really,
like
it's a really good tool.
I think TestStand 2019, I think, has integration with NI Package Manager as well.
It
So when you
creates
create like
packages,
TestStand
deployment.
deployments, you can create them as NI package manager packages, which is, I think, probably the way to go forward instead of using the TestStand deployment utility.
Yeah. It's from 2017, but it's only supported for 64-bit. So if you're using 32-bit, you don't have support. So.
I think the only reason we haven't gone that way is because it requires the engineers who are creating the sequences to know more about TestStand.
Yes,
so
yeah,
we just tried to abstract that away from them and just give them the dialogue with stuff they're familiar with.
Yeah.
So one other little thing to mention about NI Package Manager, it does unfortunately need admin rights in order to run. Just even to open, you need admin rights, which in our organisation at Dyson is a no-no. Nobody has admin rights, apart from a select few people. But in order to get all of our engineers at Dyson to be able to use NI Package Manager, we actually were in discussion for 6 months with our IT department to come up with a way. It is facilitatable by creating a generalized user account for your company, which does have administrator rights to everybody's PC with a incredibly long, intense password. Of course, that's uncrackable. This one user credential is the thing that's actually running your NI Package Manager, and they use a PowerShell script compiled into an executable to hide away its workings, such that we now have 2 links. We've got NI Package Manager you can click on, which you need admin rights for, or the Dyson NI Package Manager, which still launches NI Package Manager, but under a different user credential set, which gives it the admin rights and allows you to install stuff. So you can work around it, but NI again have promised, looking into the future, they are trying to find a way of putting leveled elevation of sort of rights required in order to do things. So just putting some files onto your desktop shouldn't require any rights, whereas changing your program files folder should. So they're trying to split that up, but I don't have a huge amount of confidence that it's going to be here within the next couple of years. So
I think with Windows 10 that doesn't help either, because at some level you can't even write to C:, you can't create folders on the C drive anymore.
You need admin rights for
You need
that.
admin rights for that.
yeah, no, it's fundamentally made it difficult.
But then VI
generally.
Package Manager manages to do it without admin rights.
Which package manager?
VI Package Manager.
Oh, VI
JPI.
Package Manager. That is true.
It writes in the
Anything
program
on C,
files.
does it? Doesn't put it any.
Well, it just
anywhere
stuff in
that's
VI
not-
library, doesn't it?
It puts in program files,
Yeah, I guess
which is equally protected.
No, I don't think program files is. I think you could create a folder in there and you can add stuff.
One
Yeah,
thing I've kind of
C
noticed,
drive.
so having played a bit with Linux, Linux has real file permission control. You can set who creates things, what you can copy, paste, anything. I'm imagining Windows is kind of moving in that direction as well with Windows 10, because some program files folders, I have no ability, when I'm not in my admin account, I can't do anything. It just tells me I need admin rights. But other ones, I can, and I think it's down to when the MSI installer that's installing the application in program files, it can register whether something is got the, well, you can set different levels of permissions as to who can do what with the file. So I suppose it just depends on the program.
Yeah, I mean, one of the things is if you're building like a LabVIEW application, or maybe it's an installer actually, there's an option which is unlock. And that option, if you tick that option, it allows when you it's a LabVIEW installer. If you tick that option in the build spec for the folder, so if you install something to program files, my data, if you tick the unlock button next to that folder, then that allows you to install and write stuff to it without admin rights.
Is that what that's for?
That's what that does.
That's actually really useful.
Otherwise you can't.
Yeah.
But yeah, that's basically if you want to have your program be able to write to stuff in its own directory, like when you run it as a user, you have to tick the unlock button when you
I
install
see,
it.
because
and
I've in the
that's what-
past, I've made something install something into its own program directory folder, and then
Yeah.
afterwards I suddenly can't change the program data's folder, which anybody should be able to really, because that's literally just program data. Especially its own application.
Yeah,
There
so
you
I think
go.
that's right.
Unlock,
But
that's
but
cool.
also, I mean, generally the guidelines is follow Microsoft's recommended advice for where to put things. So user folders, program the sort of hidden program data folders and that kind of stuff. If you follow those guidelines, then you're in a better place.
Cool. Well, that's it for what we have to talk about. Thank you very much for listening to us.
Any more questions?
Any questions?